Good evening students. So let us move on to the next method of speed control of three-phase induction motor. The next method of speed control of three-phase induction motor is rotor resistance control method. Okay, so in this method we control the resistance, we vary the resistance of the induction motor. But this type of method is only applicable to the wound rotor induction motor. Why? Because wound rotor induction motor has got slip rings and the external resistances can be only inserted in those slip rings. No of the resistances can be inserted in the squirrel cage induction motor. So the squirrel cage induction motor cannot be used with this method. This method is only applicable to the wound rotor induction motor. Okay, so let us start with the torque equation of the three-phase induction motor. We have already seen it. The torque equation of the three-phase induction motor is given by T is equals to 3 upon 2 pi ns s E2 square R2 upon R2 square plus S x2 square. Okay, so this is the torque equation of three-phase induction motor. So at the maximum torque is attained when my R is equal to S into S x2 naught. When my R is equal to this, then I attain maximum torque. So my maximum torque is given by Tmax is equal to 3 upon 2 pi ns s E2 square R2 upon R2 square plus R2 square. Instead of S x2 naught square, I can put R, because when R is equals to S x2 naught, when R is equals to Sx, then I attain a maximum torque. So maximum torque is attained when my resistance is equal to the reactance. So from here I get 3 upon 2 pi ns R2 s E2 square upon 2 R2 square. My R gets cancelled. Instead of R2, I replace this R2 by S into reactance, Sx2. I can replace it with Sx2. Okay. So my Tmax will be equal to 3 upon 2 pi ns s E2 square upon 2 x2 naught. So ultimately my torque equation is not depending upon the resistance. It is independent of the resistance. My maximum torque is independent of resistance. Is independent of resistance. Okay, so but my resistance is depending upon my slip. Because when my condition was R is equals to S into x2 naught, then only I attain the maximum torque. So maximum torque is independent of the resistance, but my resistance is definitely depending upon the slip. So my R is equals to S x2 naught, and my R is directly proportional to S. So here my slip is depending upon my resistance, and also I know my NR is equal to 1 minus S into NS. Okay, so my rotor speed is also depending upon my slip, and my rotor speed is also depending upon the resistance. Okay, so when my R is equals to Sx naught, I am getting my Tmax. So let us draw the torque slip characteristics in order to understand this concept. We have already seen the torque slip characteristics and torque speed characteristics. So let us draw the torque slip characteristics first. So let us say I'm having my Tmax over here. Okay. So when my resistance is R1, let us mark it as Tmax. This is my torque and this is my slip. Okay. So let us mark it as T1. At the T1, my slip is S1. Okay. At R2, at the resistance R2, my slip is S2, and at R3 my slip is S3. Slip is S3. Okay. Let us say my slip over here is 0.1. Let us say my slip over here is 0.25. Let us say my slip over here is 0.5. So as my resistance are increasing, my slip is also increasing, and from here also, and I'm getting a maximum torque Tmax over here, which is the breakdown torque. We have already seen in the torque slip characteristics and torque speed characteristics. So as soon as my resistance is increasing, my slip is also increasing, because my R is directly proportional to the S. But that condition is only attained when my torque is maximum. When my torque is maximum and my torque is constant at that time. My torque is maximum and my torque is also constant at that time. Okay. So over here I'm getting R3 greater than R2 greater than R1. So my slip will also be S3 greater than S2 greater than S1. Okay, it will be S1. So as my resistance R1 is lesser than R2, R2 is greater than R1, R3 is greater than R2, so my slips will also be the same in the same manner. Now let us see what is the effect on the speed of the rotor. What is the effect on the speed of the rotor? Because ultimately we have to control the speed only, and this is the method for controlling the speed only. So naturally, when my slip is changing, when my resistance is changing, my slip is changing, so my rotor speed will also change. So my rotor speed will also change. So my rotor speed is given by NR is equals to 1 minus S into NS. So as my slip is changing, my rotor speed will also change. When the value of S is 0.1, then my NR for the first case, when R1, when my resistance is R1, so my NR will be 1 minus 0.1 into NS. Okay. So my NR will be somewhat 0.9 NS. Okay. When my resistance is at R2, my NR will be equal to 1 minus 0.25 NS. So my NR will be equal to how much? My NR will be equal to it will be 0.75 NS. Okay. And when I'm considering my resistance is R3, then my slip is 0.5. So my NR will be equal to 1 minus 0.5 into 5 into NS, which will be equal to 0.5 NS. Okay, which will be equal to 0.5 NS. So ultimately, what I am seeing over here, in the first case NR was 0.9 NS, the factor was little bit greater. Then as my resistance increased, my slip also increased, so my factor decreased. Then my NR decreased by the factor 0.75. Then again my resistance when increased, again my slip increased, but my NR decreased by 0.5 factor decreased by 0.5 factor, okay, because it has become nr equals to 0.5 ns. So ultimately my speed is decreasing, so with the increase of resistance my slip increases, but my speed decreases, so we can also attain, when increasing the resistance, we can attain maximum torque at the decreasing of the speed, even at the low speeds. So the major advantage of this method is, now what are the advantages and disadvantages of this method? The major advantage of this method is that the torque capability remains the maximum, it remains the constant even at the low speeds. Although we are increasing the resistances, so hence we are increasing the slip, but the speed decreases, and so even at the low speeds we can attain the maximum torque capability and the torque remains constant. So that is the major advantage of this method. Now let us jot down what are the disadvantages of this method. The disadvantages are that, first of all, we cannot use this method for the squirrel cage induction motor. If we need to apply this for the squirrel cage, the method gets failed over here, because in the squirrel cage we do not have the slip rings and the resistances cannot be inserted in the slip rings, okay. So we cannot apply this method to the squirrel cage induction motor. This is one of the major disadvantage of this method. The another disadvantage is that the efficiency is very low. And the third disadvantage is that there are losses in the brushes, because slip rings, the resistance are inserted in the slip rings, so brush loss is very much high. So losses pertaining to the brushes are very much high. So the another disadvantages of this method is that the brush losses are very much high, okay. So this method basically is used where we want this torque capability as constant, maintaining the torque capabilities. This method is basically used where the torque capability is maintained constant, okay. So let us jot down the conclusion. Yes, if we want to show over here the speed will decrease like this. Speed will decrease over here like this, and RNS will also decrease, and also the NR will also decrease, okay, and R will also decrease. So the speed will decrease as we are increasing the resistances, and as we are increasing the slip, the speed is decreasing. So conclusion, let us jot down the conclusion. Conclusion is that when resistances are increased, slip also increases. With the decrease in speed. But maintaining the torque capability. Maintaining constant torque capability. Okay, so this method was about the rotor resistance control. We were just controlling the speed with the help of the resistances. We were adding the resistances, we were increasing the resistance value, and hence the slip value was also increased, because we know that maximum torque is attained when R is equals to S into x naught. This is a condition for attaining the maximum torque. So what happened when we increased the resistance? The slip also increased. When the slip increased, what happened? my speed decrease, and I got the control over the speed. My speed decrease, but the main advantage was that the torque capability do not change, it remained the constant. Okay, so this was this method, and in the next video we will be studying about the next methods of the speed control of induction motor, pole changing, etc. The methods, the more methods, and also we will be studying about the transformer induction motor, how they are related to each other, the equivalent circuit of the induction motor, that also we will be studying in the next lecture. Okay, so please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.